interaction is the most essential form of human activities, and we all spend a huge chunk of our lives interacting with other people. Going out with friends, meeting with colleagues, negotiating with clients, or spending quality time with our family. Even when we watch TV or play games, we're spending time observing actors or avatars interacting with each other.
The most traditional form of social interaction is face-to-face conversation, where we use speech and also body language to communicate with another person. What we call verbal signals, speech, and non-verbal signals, body language. However, nowadays the use of technology such as social media, text messaging, e-commerce is replacing many forms of face-to-face interaction. We could get a sandwich from a supermarket and use self-checkout without having to speak to anyone, or discuss and make decisions with our colleagues via email without ever meeting them.
But even when some of the social activities were removed or moved online, it is important that we could still express ourselves through the verbal and nonverbal channels we are most familiar with. We can replace verbal communication by typing, but nonverbal signals are more difficult to be directly translated into words. That's why we often use emoticons. They're little icons which express emotions, a happy face or a sad one with tears.
But there are problems. First, it's hard to use this limited range of emoticons to capture all the emotional expressions we use. Although there are a set of universally recognised basic emotions, we're all unique in how we express ourselves. By trying to digitise our emotional expressions, we risk losing our personal identity. Second, interaction implies it's reciprocal. It's a real-time exchange of information with another person. In a face-to-face interaction, as we're talking, we're also listening, and as we express our emotions, we're also observing. Often, before I finish my point, I already know if my friends agree or disagree with me from their face and body language.
Online communication often oversimplifies or removes real-time social signal exchanges. For instance, you might send an email to your colleagues today and they will only read and reply to it tomorrow. As a result, this can be unsatisfactory and even frustrating for many.
Social interaction in virtual reality sits in between real and digital social interaction, and often can be a mixture of both, depending on the specific application.
Many social VR applications are about the ability to interact with another person in real time. In this case, the aim is to capture as much as possible our expressions and apply those to the digital representations of ourselves, our avatars. So we can have high-fidelity social interactions where we can not only hear each other's words, but also sense their emotions through their nonverbal cues.
There are a lot of things that can go wrong. We need to have a good microphone to capture what the other person is saying and a good set of headphones to play this in real time. The same applies to our facial expression and body language. We'll need to capture these non-verbal cues to animate the virtual reality representation of ourselves in real time. This is by no means a straightforward procedure.
And in virtual reality, this person you are interacting with does not have to be a real person. It can be an autonomous agent whose behavior is generated by computer algorithms. And just like other human beings, they should be able to understand what we say and feel our emotions through our facial expressions and body language, and respond to us in real time.
And in order to do this, we'll need the power of machine learning and AI. And it turns out that although machines can be very good at playing chess, they're not particularly good at socializing with human beings. Having said that, there are a lot of tricks you can play that give the illusion that the computer-driven virtual humans are responding to you in some ways, just like the other illusions you could get in virtual reality.
So in this course, we'll teach you everything you need to know to get started in designing and implementing your own social VR applications. We'll teach you the theory and design principles behind virtual characters, what to consider for different types of applications, and most importantly, the unique features of VR which make it a useful tool for social interaction.
You'll also get your hands dirty in making your own social VR application. We'll show you how to implement simple tasks, including how to import a virtual character into Unity, how to put some basic animation on them, and how to create the illusion that the computer-driven virtual humans are responding to you as if they were real.
Can I please start this video by introducing an old friend of mine, Christina. She was the very first avatar I have ever created in 2005 when I was doing my master's project. And she was considered to be the most attractive avatar in the lab at the time. Fast forward to 2016, here is a 3D model of myself, captured with photogrammetry. I know the hair looks a bit weird, so I still prefer myself to my avatar until this can be fixed. Anyway, the point is that in the past 10 years, we have become a lot better in modeling those virtual characters. We have also improved our ability to animate them to behave as if they were real and program them to be interactive. This gives us the ability to create realistic, expressive, and responsive virtual characters, which have laid foundation for having meaningful social interactions in virtual reality. Christina and my own 3D model, let's call her Sylvia Jr., are both virtual characters. Christina is more like a comic figure, and Sylvia Jr. is more like a real human. In this case, we say that Christina is cartoon-like, and Sylvia Jr. is photorealistic. There's one thing Christina and Sylvia Jr. have in common. They're both human-like avatars. That is, both their body shapes and facial features are designed to resemble those of a real human. Not all virtual characters are designed this way. Some, for instance, are designed to look like robots rather than humans. Some of them are humanoid robots, often called androids, where their body and some facial features resemble those of real humans. We also often see virtual characters designed to look like monsters or animals, or even just objects, but with human-like behaviors. For instance, the characters you often see in animated films. In the Pixar film Cars, there were several anthropomorphic cars, and in the movie Toy Story, there were toys who express human emotions. Finally, in the simplest format, virtual characters can be quite abstract. A good example is the game Pac-Man, where you have Pac-Man, the player character, and the ghosts. They are the enemies who chase Pac-Man. So we can rank virtual characters by their human likeness. On top of the rank are Sylvia Jr. and Christina. They're both human-like virtual characters, but Sylvia Jr. is more realistic than Christina. At the bottom are probably abstract characters, such as Pac-Man and the ghosts. In the middle, you can have a range of virtual characters. Some look more like robots, others like monsters, animals, or even anthropomorphic objects. As long as they are designed to be able to behave with humanistic characters or personalities, they should go into the big category of virtual characters. So far, we've been describing mainly the appearance of virtual characters, or visual fidelity. How real does a virtual character look? However, when it comes to the realism of a virtual character, there is something else that is considered even more important than how much they look like a real human. And that is how much they move like a real human, or motion fidelity. Motion fidelity is often considered more important because there is more work. You define the visual fidelity when you model your virtual character. Sure, there is a lot of work, but once you are done with the modeling, your virtual character is there. Motion fidelity, on the other hand, requires you to think carefully about the animation you apply on the virtual character for each frame. If you have a frame rate of 60 Hz, in order to produce a 5-minute animation, which is 300 seconds times 60 Hz, you will have 18,000 frames to worry about. Another reason why motion fidelity requires a lot of attention is that it actually sets the bar for how far you should go in terms of visual fidelity. If you have limited capacity in terms of how realistic you could animate your virtual characters, you should avoid using highly photorealistic virtual characters. Instead, you should go for more cartoon-like or even abstract virtual characters. You should avoid having low motion fidelity animation with high visual fidelity virtual characters, as this will make the avatar look cold and even creepy. This is because the visual fidelity sets the expectation. A highly realistic looking virtual character makes you expect highly realistic motion. And if this expectation cannot be met, the whole experience loses credibility. In the worst case, it even breaks the plausibility illusion, which is very important in sustaining immersion in VR. We're all very familiar with virtual characters, as we often see them in games or animated films. However, there is a major difference between virtual characters in these two types of media, which has important implications in terms of how they are designed and implemented. Characters in animated films are often non-interactive. They might be interacting with each other, but we can only passively watch them either in the cinema or on TV. When we watch them at home, we can choose to play or pause the film, but there's nothing we can do that could change their behavior directly. Characters in games, on the other hand, are often designed to be interactive. That is, they can react to our own actions in real time as we play the game. Generally speaking, there are two kinds of virtual characters in games. One represents the player and is often referred to as an avatar or player character PC. The other is a computer algorithm-driven virtual character, often referred to as an agent or non-player character, NPC. For instance, in the game Pac-Man, the character Pac-Man itself is an avatar or PC because it can be directly controlled by the player. The ghosts, on the other hand, are driven by computer algorithms, and they are called agents or NPCs. We often have multiple agents in a game. In Pac-Man, there are several ghosts, which make the game more interesting as we're chased by several enemies. Some games have multiple avatars, as they can be played by multiple users together. The players of these games can be in the same physical environment, they can be playing the same game sitting next to each other, or they can be together only virtually. For instance, they can be playing a game in their own living room, but online their avatars are sharing a virtual space where they can collaborate or fight with each other. This type of game is often called a massively multiplayer online game, or MMOG. Both agents and avatars could be interactive. In order to achieve this, these virtual characters should be rendered in real time. That is, the graphical representation of the characters are calculated and displayed in real time each frame. As a user, my actions at the current moment could change the character's behavior for the very next frame. In Pac-Man, I can control my Pac-Man avatar using the keyboard to navigate around the environment. The trajectory of its navigation is fully controlled by me. As for the ghosts, although they are controlled by the computer algorithms, their behavior is also influenced by the player. They were programmed to dynamically change their navigation path depending on the player's position and movements. In traditional games, we can control our avatars with game controllers with which we can navigate around the environment, shoot bullets, or select what to do next. In some games, we have a third-person perspective. We see the environment from behind the body of our avatar, so we can see where we are going to as well as the body of our avatar. In other games, we have a first-person perspective, so we see the world from the viewpoint of our avatar. for instance, in a driving game, we normally have the perspective from the viewpoint of the driver behind the driving wheel. We can only see what's in front of us, so we can't see the full body of our avatar, but we might see the hands of our avatar on the driving wheel. In virtual reality, in most of the applications, we should have a first-person perspective. So we observe the world from the viewpoint of our avatar. We should also be able to control our avatars using our own body. With the current high-end VR systems, our head is tracked with the VR display and our hands with the controllers. In an ideal VR system in the future, we should have more body parts tracked so we can really fully express ourselves in VR through our avatars. This will allow us to use our body to interact with objects and navigate in the virtual world and engage in social interactions with other agents or avatars, just like we do in real life. In real life, we spend a lot of time interacting with other people. In virtual reality, we interact with virtual characters instead. The character can be an avatar, a representation of another real person, or an agent, a character driven by computer algorithms. But actually, as the ability for computers to generate socially meaningful human-like behaviors is still fairly limited, and for certain applications, human expertise is still needed, sometimes the virtual character can be a mixture of an avatar and an agent. Here, I'll use some examples of work I have done in the past to show you how we designed and implemented those virtual characters, and how they played a critical part in those applications. I will show you two applications: psychotherapy for social anxiety and training for medical doctors. Let's start with psychotherapy for social anxiety. People who are too anxious in social interactions tend to avoid social encounters whenever possible. But by doing so, they're also missing out good opportunities to practice their social skills. And the less they practice, the more anxious they become. So they found themselves in this vicious cycle. A way to bring them out of this is for them to practice social interactions with a virtual character, so they can expose themselves to the anxiety in a risk-free and controlled environment, where they can safely practice their social skills. We can also design the environment to be a very positive experience, so it's easier for them to get started, and gradually we increase the difficulties when they are confident with the current level. So here is what we did in 2005. This is how the interaction between Christina and our participant started.
Hi, it looks like we are the only people alone here, right?
Yes, it does.
My name is Christina.
Hi,
What's your name?
My name is
Very nice to meet you.
Same to you.
So, what are you doing for a living?
I'm currently a student at the moment. I'm doing a degree in London.
Oh, very interesting. Tell me more.
I'm a second year student studying.
And later, this is when the interaction becomes a bit personal.
I feel a bit shy about talking with other people. Do you mind if I talk with you for a bit longer?
Well, enough.
If you don't mind me saying. I look very nice.
Thank you.
I was wondering, actually, are you single or involved with someone at this time?
I'm kind of sick.
Actually, it is the same with me.
How long can we stay?
Anyway, what are you doing after this party?
I don't know, to be honest. I don't really have any plans.
Alright, I see.
When implementing this application, we prepared a database of short animations, including facial animation, lip sync, and body animation. Each short animation also had an audio clip attached. An experimenter was listening to the conversation in real time to select the appropriate response to trigger. So in this sense, Christina is the avatar of the experimenter. However, there were also other things going on. She maintained eye contact with the participants and looked away every now and then, just like we do in real life. She also kept a fixed interpersonal distance with the participants and moved closer to the participant in the second half when the conversation became more personal. Both of these two features were driven by computer algorithms. So in this sense, Christina is an agent. Overall, most participants found the whole interaction very realistic and pleasant. Even participants who were quite shy had a nice time and enjoyed themselves, which was exactly what this application was meant for. The second application I'd like to show you is implemented with a similar method. But this time it is designed for medical doctors. Before I show you the video, here is some background. In some countries in the world, you will need a prescription for antibiotics. This is because antibiotics are not always good for our health, and overuse of them is leading to the growth of superbugs, bacteria that have become resistant to antibiotics. If this trend continues, in the near future, antibiotics will stop being effective, and we risk going back to the pre-antibiotics era, where everyday infection will become untreatable and potentially fatal. So, United Kingdom is one of the countries where you will need a prescription for antibiotics. And medical doctors here have the responsibility to only prescribe them to those who really need them. But it is often easier said than done, as sometimes it is hard to argue with patients who think they know the best for themselves. Medical doctors are often pressed to prescribe antibiotics to those who do not really need them. So, using a similar method as we did previously, we developed an application in virtual reality to help medical doctors to practice their communication skills in dealing with unreasonable demands from patients. Here is what we did.
Hi, hello. I'm Dr. Gardner. I don't think we've met before. Hello.
Hello, doctor. I am glad I finally get to see you. We've been waiting for an hour. We really need to get this sorted as soon as possible. My mother cannot see very well, so I have to drive her here. But we're going away for a couple of days for a wedding in France tonight, so we're in a bit of a rush.
Right, okay.
What can I help you with this morning?
Yes, I'm feeling okay, but since a couple of days ago, I started having a bit of sore throat. This morning, I developed this cough.
Okay. And prior to this morning, how were you feeling?
I feel okay most of the time, but this cough.
Okay.
My mother had exactly the same thing last year.
Right.
It started just like this. A couple of days of sore throat, then a cough. But then she became really very ill with a high temperature fever. I had to take a day off work to take her to the hospital. They gave her antibiotics and she immediately got better. So all she needs is some antibiotics this time.
Okay, I hear what you're saying. But what we often see is with this kind of illness, things settle down by themselves. In the most case, it sounds like you had a bad experience last time, but I think it would be worth trying some simple treatments like painkillers and some fluids and some rest first.
I'll just ask your daughter if she knows about whether you've been coughing up any phlegm or not. Do you know?
Why do we need to wait until things get worse? Her immune system is not very strong, as you can see. There's no point letting her suffer through this. All we need is some antibiotics.
Sure, no, I understand that, and if the reason I'm asking these extra questions, and I know you're in a hurry, but the reason I'm asking these questions is because actually, very often, a cough is caused by a virus rather than a bacteria.
Even if it is just a virus, isn't it better that we give her some antibiotics to help her immune system?
Well, unfortunately, that's not how antibiotics work. They don't. They don't boost the immune system.
Please, can you give us the antibiotic prescription now? And we will only use it if things get worse.
As I say, I don't think that's necessary right now. Sometimes we can do delayed prescriptions, but I've examined your mum right now and she looks fine to me, and I think this is a virus.
Doctor, maybe you can give us the prescription, but we will only collect it if my mum gets worse.
Okay, it seems like that's something you're both absolutely fixed on having. We can arrange for a prescription that you can pick up tomorrow or the next day if things are getting worse.
Reassuring as I can, I do not think that there
This
is...
is so unfair. It's going to ruin our holiday. I'm going to take this up with the local health authority. I think you are unfairly denying medicine to my mother.
Okay, I appreciate your concern. Thank you for your feedback. I do think that the best medical practice at the moment is to manage this conservatively for now.
My mother worked and paid national health insurance all her life. Now look at what's happening.
Sure, I mean this has got in no way to do with your mother's health insurance payouts. I believe this is the best medical practice at the moment for your mum. I think the use of antibiotics in terms of the risk and the side effects that they can produce, such as resistance to future chest infections or problems with the stomach, mean that it's probably better to not prescribe them and to seek medical attention in France should things get worse, which I'm not
They
expecting.
say on the news that old people are just invisible, not treated with respect by the NHS.
Okay, I appreciate your concerns. Thank you very much for
I
sharing.
suppose that this is all government cuts to the NHS, but that's just an excuse. You could give us the antibiotics if you wanted to.
Well, I don't think it would be good clinical medicine, as I've explained before. I'm very sorry to have to cut the conversation short. The reception have asked me to see the next patient as an emergency. I truly wish you have a good holiday, and if you develop chest pain, shortness of breath, or a change in the colour of the sputum that you're producing, I do think you should seek medical attention while you're away.
Animating human-like characters is much more complex than animating other objects. Humans generally do much more complex things than tables or chairs, and we're much more attuned to human movement than to that of other things. We will notice very small errors in human movement, which we just wouldn't notice in the movement of a car. We generally divide character animation into movement of the body and movement of the face, and use different techniques for each. Body movement is all about movement of the skeleton. Our bones are hard, so they don't change shape much. Instead, most of the movement comes when we rotate our joints, like the elbow. This means that the skeleton is the key thing that we animate. The face, on the other hand, only really has one movable joint, the jaw. But there are still very important movements and social signals in our facial expressions that come from small movements of the muscles of the face. The eyes are probably the most important part of the face when it comes to social interaction, and they use different techniques again. Like bones, it is very much about how they rotate to look at things. There are two basic ways to animate characters for VR, using pre-recorded animations or generating movement using procedural simulation. A pre-recorded animation is a sequence of poses of the character that can be played back to create movement. They could be hand animated using keyframe animation, or recorded from a real person using motion capture. This kind of animation is not that flexible. You can only play back what was recorded, and it can't be adapted to what you need in the moment. But you can use different techniques to select an appropriate animation clip in response to what is happening. Unity uses a method called state machines. The benefit of pre-recorded animation is that you can achieve complex and realistic movements, so it's well suited to sophisticated full body or facial movement. Procedural animation is about generating movement in real time from code. A script controls how the character moves in response to what's happening. It's much harder to create complex realistic animation using procedural animation, but since the animation is generated from scratch as the program runs, it's much easier to respond very exactly to what the player's doing. It's good for things like eye animation, where the movement itself is quite simple, just rotating the eyes in their sockets, but you want the eyes to point in exactly the right direction. In the next couple of weeks, you'll learn a lot more about animating characters, both how to animate and what to animate. And very soon you'll be creating realistic VR characters.
It's hard to believe that it has been over a decade since the two of us started working together.
One of the first major projects we worked on together was developing an interactive agent to use in some of our VR experiments. We called her Christina. We'd like to talk a little bit about the challenges we faced and how we solved them, because a lot of it is still relevant today.
Christina was able to carry on a conversation with a real person who was immersed in VR. Her graphical appearance wasn't great, even by the standard of that time. But what made her interesting was that her body language was quite realistic. And most important of all, it responded to the participant.
Speech interaction isn't easy now, but back then it was a big challenge. Getting a character to respond realistically with dialogue was beyond what we could do. Because Christina was going to be used for experiments where there'd always be an experimenter present, we decided to use an approach called Wizard of Oz. Essentially, we faked interactive conversation by having an experimenter choose what Christina was going to say from a number of options in a menu, just like the wizard in the book.
On the other hand, this wouldn't work for a lot of the body language. Our body language responds to other people very quickly. The experimenter wouldn't be able to choose gestures and movements quickly enough. Also, we mostly do body language subconsciously, so we aren't really aware of what we're doing. That means it is very hard to explicitly control it for a character.
So we decided to automate a lot of the body language. That involves sensing the behaviour of the participant and producing realistic responses. The sensors we had available are very similar to what we have now on head-mounted displays: a head tracker and a microphone. The most important information we needed to know was whether Christina was speaking or listening.
Speaking was easy. When the experimenter pressed a button, we just played back a particular piece of speech until we finished. For the audio, we recorded an actress reading the script. We then hand-animated body and facial animations to go with the audio. Our software played back the audio and animations together to make Christina speak and gesture. In later experiments, we motion captured actors as they read out the lines and used that animation, which gave more realistic results.
Listening behaviour was, if anything, more important. It created the illusion that Christina was really paying attention to the participant and made her feel real. We used the microphone to detect whether the participant was speaking or not. And when they were speaking, our software would occasionally play back nods and smiles to give some friendly encouragement. Christina's eyes were also very important. We had a simple automatic gaze animation where she would alternate between looking at the participant and looking away. Importantly, we changed the proportion of time she was looking depending on whether she was speaking or listening. She looked a lot more while listening to show attention.
This has proven to be quite effective. Take a look at this video clip and please pay attention to his body language.
That shirt looks great on you. How much was it?
I think it was about £20. It's quite cheap. Thank you very much, though.
You look very nice too.
Oh, thank you very much.
Here, the participant was clearly enjoying the interaction very much. So much so that he moved all the way to the back wall of the cave in order to get closer to Christina. What he didn't know was that we have also programmed Christina to maintain a social distance from him. So the closer he moved, the further back Christina moved. She would move to make sure that she was always at a comfortable distance to the participant. Christina would always turn to the face of the participant as you would naturally do in a conversation.
And in one experiment, we reduced the distance midway through the conversation, making her move forward and increasing the sense of intimacy. This had a strong emotional impact on our participants.
So Christina had quite realistic body language and had a strong impact on participants, using only a few simple rules that you can reproduce with current VR technology. The rest of this course is going to explain how to do some of these things and create socially skilled virtual characters.
Hello, I'd like to welcome Dr. Harry Brenton, Director of Bespoke VR and Immersive User Experience Designer. Harry, you've got lots of experience designing virtual characters for VR. What do you have to think about when you're designing a character?
Well, there's quite a well-known theory called the uncanny valley, which basically says that as a character gets closer and closer to a human being, you're fine, and suddenly there's a sharp drop-off where it gets really eerie to kind of interact and to look at the character. And that's one of the kind of most well-known, it's not a design rule, and there's still quite a lot in the research that's not known about it, but that's something which designers certainly avoid. So what people tend to do is dial down the levels of realism so that they avoid that kind of uncanny zone. But that raises a really important issue about what level of realism you're going for, and then how you match that realism to the way the character behaves. And it's really a balance, like a lot of things in design. It's a balance between matching the way a character looks and the way a character behaves, whether that's an avatar or a non-player character.
So if a character looks very realistic, but actually their movement is a bit clunky and weird, that can cause problems.
Yes, it can create a mismatch. Also, if you've got an avatar and you look in a mirror and the avatar's got eyes, but you don't have eye tracking, it's always going to look weird because the eyes are just going to be kind of look dead. And you can put scripts on the eyes to kind of make them blink and things, but it's always going to look a little bit weird. And if you look at the Oculus avatars that were released, what they do is they have sunglasses on. So they get around the problem of not tracking the eyes by blocking the eyes with sunglasses. And they only show the hands and the neck and the head movements. So they're only representing bits of the avatar that receive direct motion capture. And if you look at some of the interviews with the people that designed them, they're very careful to directly reflect the motion capture data. So they don't add animations or blinks. They just show the animation that's captured.
So having a more simplified, abstract representation of a person can actually make for a more realistic experience?
Absolutely. And I think there are a lot of the lessons from kind of comic strips, and I'm thinking of, there's a great theorist called Scott McCloud, is actually by stripping back the levels of realism, you can say quite sophisticated things because the realism doesn't get in the way of, say, some movement. And some of the tricks of animators of kind of stylization and exaggeration can come into play. So even though you're making it look more simple on one level, it doesn't mean that you can't have a sophisticated kind of character or interaction.
So maybe it's time to talk a little bit about interaction. How do you design an interaction with a virtual character? How do you design for social VR?
I think two of the most important things there are space and body language. So the rule of thumb is we care very little about things that are far away, and we care a lot. And there's a lot of our brains that are devoted to thinking about things that are close to us. So how you position a character and how they move in and out of your personal space is very important. And I mentioned a while ago about the robot dog in the lab. And what's nice there is that the dog goes out when you throw the stick, and then he comes back in again. And there's something inherently pleasing about that kind of exiting and coming back into your personal space. Body language is a lot more complicated than it seems at first. So if I'm kind of talking to you and I'm just looking up there, that's a really strong cue to you that I'm not listening to you or that I'm behaving inappropriately. And if the second I do that, that kind of breaks it. So you have to get the body language right, but you have to continually get the body language right. And that's more of a challenge than you think.
So you've talked about the Oculus avatars and multiplayer social VR. How is working with non-player characters different from working with avatars and multiplayer environments?
Well, I think multiplayer, so I'm thinking some of the early multiplayer games and experiences like Toy Box, they kind of make it look easy because you've got another human there to do that moment by moment reaction. They kind of sell the illusion that this is a plausible human being there. But actually teaching a non-player character those rules, it works in some contexts. So again, with a dog fetching a stick, I can create some simple rules which say, fetch the stick, start begging. But when you want to try and simulate slightly more complex social interactions, those rules can break down because essentially the rules hit the limit of what the coder or the designer think people behave like, but that's not necessarily the way people actually behave. And again, body language is complicated because there are things we do that we're not really aware of that happen subconsciously. And it's very hard to teach a computer subconscious rules.
So is that one of the big challenges we have as VR designers?
It is. I don't think that users will phrase it in those terms, but they'll just see something as odd or something that doesn't feel quite right. And again, going back to the idea of the uncanny valley, there's something that is just a little bit eerie or a little bit kind of off-center about an interaction. But as a designer, having some kind of understanding, and these are just theories, the uncanny valley is a theory, but it's a good way to kind of hang your thoughts about it as a designer on, because then you can test different approaches. And I think we're still quite far off from, I think, really photorealistic interactions with photorealistic virtual humans. But I think in the next 10 years, for sure, we'll get a lot closer to that.
So that's one of the really exciting things we can look forward to, both as users and designers of VR, is really creating fantastic social experiences.
Yeah, absolutely. And I think specifically better non-player characters, because as the massive multiplayer VR worlds kick in, and I think there's going to be a lot of activity on that next year, people are going to be much more aware of when non-player characters aren't working well. And that's a really interesting area of research, I think.
Okay, great. Well, thanks a lot, Howie, for your time and sharing your experience with us. And I'm sure our learners have learnt a lot. So thank you very much.
Pleasure.
Hello everyone! In this video, we will explore different methods to bring virtual characters into a Unity project, including using the Asset Store, Mixamo, and custom models. So let's get started. Unity's scene open here with a plane to place my avatars, a directional light, and a main camera. So there's three ways usually of importing an avatar into your project. One of them is by going onto the Asset Store and downloading an avatar. Another is to use a a specialized website where you can download from an external source, such as Mixamo. So I have the example here. Sign into Mixamo, create an account, and you can access characters and animations. And you can also create your own avatars, rig them, and import them into Unity. Now, I have here an avatar that I found on the asset store, and I'm going to just save that. So I've done it already for the sake of time. Save that, and I've opened it in Unity. So when you're looking at avatars to download, it's important that you check the type that is compatible with Unity. I believe that the types that Unity can take in is FBX, and it can also take in OBJ files. And it's always best to kind of check the other formats that Unity can take in. You can also save your 3D files if you're creating your own models from most common 3D modeling software in their native format. So .max, .blend, .mb, .ma. And Unity finds these file types in your asset folder. It calls your 3D modeling software's FBX export plugin and imports the file correctly. Well, that means that the 3D modeling software must be installed on the same computer as Unity. But in this case, we're going to download this gentleman humanoid. So we already know that it's a humanoid type rig. And we're going to open it in Unity, import it, and this will open up our package manager, which we can also access from the Windows tab here. And this will lead us to the folder for our assets, the ones that we've already downloaded from the asset store. And we can now import that into our project. So I'm just going to select import, and this will open up an import to Unity package window where we have a list of all the assets that are coming with this package. And you can now be a bit selective and choose what you want to import. And it's good to actually look through this just in case there's anything you don't need, to save on a bit of space. So for example, I don't need the demo scenes here, so I'm just going to delete that. And then I might delete the animations because we're not using that right now, and we can use another set of animations later. So I'm happy with my selection. So now that's done. And if I go to my project folder, I have a new folder called Formal Avatar. So this comes with materials for my avatar, the actual model itself, a prefab already created with the avatar with and without a mustache, and a ground, like a plane. So things that are going to be put in the scene itself, the demo scene, but we've deleted that, so that's not necessary anymore. And it's pink because it's probably using materials that have not yet been converted to be used on the Unity's universal rendering pipeline. Usually that's what pink means, that either it's not on the right, it's not, the materials are not compatible with the pipeline, or that it's actually missing. So hopefully it's not because the avatars aren't, the materials are missing, but we'll check that as we're going along, because as you can see, we have the materials here on the avatar already. But speaking of the model, so we're going to go into the model folder, and it gives us a few options: without mustache, with the mustache. Let's choose the one with the mustache. The MDL has a different setup of the rig, so we're just going to ignore that. And this will open up in the inspector import settings for our avatar, right, for our FBX file. So this model is trying to set up the settings for how our avatar is now going to be appearing in our scene. So we can go through the settings and choose the options that you would prefer for your avatar. So most of the default settings are fine, but you can go through and check on a few of these settings to make sure that the project is, one, optimized, and two, displaying your avatar correctly. So for example, scale factor, convert units, to adjust how Unity interprets units. For example, if this is coming from an external 3D modeling software like 3ds Max, that uses 1 unit to represent 10 centimeters, whereas Unity uses 1 unit to represent 1 meter. So just kind of understanding the scale factor here. And you can check to optimize your meshes. So optimize mesh, reorders vertices or polygons for better GPU performance, and etc. Sometimes your avatar might come with its own cameras and lights from its platform, if that's been saved in the FBX file. And you can kind of play with how Unity handles normals, with normals and normal mode and smoothing angle and etc. So yes, have a go reading through this, but for the sake of this tutorial, everything here is quite fine for our import. We're going to go to rig now, and you can see that we have 4 options here: animation type, and avatar definition, skin weights, and strip bones. So animation type defines the type of animation to support. So Unity has essentially 3 animation systems inbuilt, and it maps your avatar's skeleton to that base animation system, right? So with none, that means that you don't have animation with your avatar. You're not planning to use animation, so you'll have no options. Legacy is the old version of Unity. So old version of Unity's animation system from the Unity version 3 point ... and etc. Generic is Unity's animation system for avatars that don't have a humanoid rig. So they don't have the 2 arms, 2 legs, and a head, essentially. So it could be a different type of animal or completely abstract. And with that, Unity picks a root node. It kind of estimates what the root node is, but then you can also kind of define that yourself. But with the humanoid rig, which we have, Unity uses the humanoid animation system, so not the generic animation system. And Unity usually detects a skeleton within your avatar and maps it to the Unity's internal avatar template for use with the humanoid animation system. So it's important that the definition for this avatar is set correctly. So leading us to our other tab here, which is the avatar definition. You can create directly from this file or from this model itself. And that means that it's going to try and map the skeleton that we have for this avatar to define our this avatar setting here. But we can also copy from another avatar if you've previously set up another avatar in your project already. Unity attempts to map the set of bones defined in the file to a humanoid avatar. So we're going to do it from this avatar because we have no other avatar in our project defined. So once we've done that, we can apply settings, and we don't necessarily need to change these settings. But again, you can take a look into the details of this by opening up reference to the model importer and checking out what these mean. So controlling how many bone weights are imported, and strip bones only adds bones to the skin mesh renderer, what renders the mesh of your avatar, that have skin weights assigned to them. And you can optimize your game objects here. And that essentially means that you remove and store the game object transform hierarchy of the imported avatar or the imported character in the avatar and animator component. If enabled, the skin mesh renderers of the character use the Unity's animation system's internal skeleton, which improves the performance of the animated characters. This is only available if you are using create from this model, but it's fine. We're not going to have too much in our project, so we're just going to ignore that and apply. And this is settings that's using a few scripts in the back end to support the rendering of our avatar. So once we do that, you can see here that flashed because it's defined our avatar here, and we can see this new asset, and we can configure the avatar. So that's created that for us. We can access it from either way, and that opens up the avatar configuration window. And here is where we have the template for our avatar. Now, usually Unity will try to auto map the skeleton here. So we've got the hierarchy of our avatar character here. We have the root bone. We're going to look from here because this is all meshes of how it's rendered. And we have the root bone with the hips, left leg, right leg, the spine, which goes to the left shoulder, or that goes to the left arm, and the right shoulder that goes to the right arm. Then we have the neck that goes to the head, and you can see that we have the hands here as well. But if you zoom in here, you see that this type of avatar doesn't have blend shades, doesn't have any animation for the face, which is fine. Different types of avatars focus and have different details of rigs in different parts of the body. So Unity will try and map this, and that's why it's so important that you have the you've named your bones in the right way that reflects the body parts that they represent. So left arm for the left arm, right forearm for the right forearm, to make it clear what those bones are controlling. Because your skeleton needs to have at least the required bones here in place for Unity to produce a valid match, right? So that's all done for us. And you can clear this and define it yourself, so drag it in yourself. It's always good if you want to have Unity to auto map it to enforce a T-pose. This is already there, so it helps Unity to find a good match. And we can auto map that, and you can see that that's done that for us. We can isolate different types of the body. So this is the neck, and we see that we have the neck and the head here, but we don't have any left eye or right or jaw here, which again is fine. Our left hand is set up well, our right hand is set up well. So when we're happy with this, we of course apply. You can also save the template that you have here if you want to use it with other avatar imports. Then you can load it through your folder. You can reset the pose, and it's not in T-pose, then you can enforce it. Sample bind pose, again, different types of posing, but again, enforcing the T-pose is better. So we're going to apply, and we can go to muscle settings, and here we can tweak the character's range of motion and to ensure the character deforms in a convincing way. So here you can preview some of these mappings, and you can shift the range of the muscle movement here. So to preview, you know, some of the movement of the body in terms of the muscle groups, we can do that. Roll in, roll out, and you can set these how far they should stretch. Again, we can do the same for different parts of the body here. And translation, degrees of freedom, can increase performance requirements, but it is good for essentially making sure that the retargeting is done accurately. And so we can select that and put that on. So if this is off, Unity animates the bones using only rotations. So we want to turn that on to enable translation animations for our humanoid avatar here. And let's save, let's apply. And let's select done. And that takes us back to the Unity window here. And what we want to do now is that we want to import it into our project. So we've done all the hard work, so to speak. Now we can actually drag it in. But before that, we can see if you did have animations, you can make sure that animations are imported. And last, we can look at the materials folder. Our avatar has already got its materials kind of sourced from our folder, and that's appearing. But sometimes this is not the case. It might appear blank without the avatar textures or materials found. At the moment, material creation mode, import via material description. So it's looking for the material description to find our materials and where it goes on our body. Then, and you can see select method used to generate materials during the input process. The location, use embedded materials, use external materials. It's good if you are using, and this is the old legacy kind of pipeline for finding the location of our materials. But we're using embedded materials, so materials are already on the FBX folder. And then if we were trying to, for example, use external, we can find the textures by base texture name or from the models material or from the model name plus models material. And this will do like a recursive search through each of the folders to find an existing material named base texture name, etc. So, but we've already got it, like I mentioned, so we can ignore this and go back to use embedded materials. We don't need to extract it because it's already on the avatar, but if it wasn't, again, we can just extract the materials here. Or we can remap external materials to use for each embedded material. But we don't need to do that. Like I mentioned, it's already set up for us. Right, so we're happy with this, and we're going to just drag the avatar into our project. You can see that it's, we're going to just, for the sake of not touching our camera, we can just turn this avatar around. And There we go. So just used the mouse, the right mouse button, and D, S, W, A to move that to the place I want. And you can see that we have our avatar imported in our scene. Fantastic. He looks great. So now he appears in our hierarchy here, and you can see again the mesh of how our avatar is being rendered in the scene. All the skin mesh renderers are here with the materials. And then we have the actual skeleton with all the bones set up from the hip to the spine. So if we actually select the formal with moustache base, you can see that we have the transform of where it's positioned in our space, but also something called the animator, which controls to Unity's mechanism system, which allows us to create states where we can toggle and move in between to select different, select the pipeline of how our avatar goes through each animation. But this is for another video. So what we can do is it puts in our avatar that we've defined. So it knows how to move our avatar. And the good thing about this is that once it's been defined and we have our humanoid rig, any avatar that has a humanoid rig will work with the same type of humanoid animation. So we'll see that in a second. Apply root motion, automatically moves the object using the root motion from the animations. Animate physics to, again, notify physics system of animated transforms. Update mode controls when and how often the animator is updated. And culling mode controls what is updated when the object has been culled. So again, we'll go through this in detail in another video, but the most important thing is that it has a avatar definition and a controller, which is how we define the mechanism system for this avatar in particular. So normally this comes with the avatar if it has animation set up, but if not, and imported, but if not, then we can just create our animation controller here. And you can see that that pops up with an entry point and an end point, and we can fill up the animations in between. So let's go back. So let's not deal with the avatar animations for the moment, but let's go back and let's go through another pipeline of importing an avatar. So this was from the Unity Asset Store, but if I was going to take from an external space, so I was going to, let's say, go into Mixamo, I've created an account, and I want to put in Michelle. So I've got Michelle selected here, and I've already got this selected. And then I can go into animations and then choose, let's delete this, choose what animation I want to put on Michelle. So the preview window at the moment is not working, unfortunately. But usually you can, let's reset camera. Nope. Usually you can see, let's see if I can just, no, so the preview window is not working at the moment, but usually you can see Michelle, and you can preview some of the animations on Michelle herself, but it will let you see, or it will say hip hop dancing, so the name of the animation on the avatar that you've selected. So again, my version today is maybe potentially slightly bugging out. Let me just reload and see if that helps. If not, then we're just going to keep going. So, this logged me out. So I'm just going to sign in. One moment. Perfect. Great. So that's, we have Michelle now in view. And I want to find a hip hop dance. So once I find the one that I like, I mean, these are great. But yeah, let's do this one. Then we can preview that. That looks great. So hip hop dancing on this character here. And so I'm going to download that. FBX for Unity with skin. So we want Michelle. We can change the keyframe per second. How 30 is fine, but we can go for 60. But again, that does affect performance, size, and etc. Keyframe reduction, we don't need to do that, and we can just download that. Brilliant. So that's going to download that into our folders. We can just save that. And I've already got that saved, so I don't want to get another one. And then what we can do is that we can go into our folder and we can go into our folder and we can just drop our asset in. So now we have our, again, another FBX file. And we can just create a folder for her. So avatars, let's just do that. And this comes with avatar, and it comes with the material as well. Let's see where that is. So that comes with an animation, material, the mesh, and the FBX file. So as you can see with this one here, it has not come with the materials in place, as I mentioned before. And let's see if I can find where it's dumped the material folder. So what we can do is, I'm just going to delete this, and I'm just going to double click. Oopsie. Let's see. We're going to try again to just drop this in here. Okay, great. So what we can do now is that this is all again set correctly. So we're going to go to rig, we're going to change it to humanoid and apply. If you go to configure, we can see that it's mapped that nicely. So we don't need to change that. And then we move to animation. And here you can see, because we have an animation, we have import animation, correct? Then we have here the clip of our dancing. We can actually see that here, previewed. And we're able to edit this to our liking before we place it in our scene. So we can loop the animation if we wanted to and apply. Again, we can check out the other options in another video. Materials is where we have the problem. We don't have this showing. So we're going to do what we mentioned before. Use external materials, search from models material. And then we're going to do like a recursive search through and see if it's found our materials. It has not. We can try from base name. And it's found it. So by base texture name, it has found our, thankfully has found our materials. So there it is. So it's gone into the folders and found the material folders, and you can see that it's now shown up, which is great. So we can go here, we can see the material here. And what we can do is, you can see that it's quite specular, it's quite shiny. So let's go into textures and let's see what our settings are. Or we can go into materials and see what the shader is here. We can see that it's using the universal render pipeline lit. Perhaps we should use unlit. Go to universal render pipeline. Unlit, that's better. Less shiny. Then we can just drag this avatar in. We can turn it around again, so it's facing the right way. And again, you can see that it has the root, the avatar root here, but no controller. So we're going to give it a controller, and we made one controller earlier. I think we did. Just going to drag that into our avatars folder. Oh. Yeah. So we're just going to call it test anim. And we're going to drag that onto our avatar here, but we can also drag it onto our formal avatar here, so they do the same animation. So let's get the animation from our import here, which is the hip hop dance. So we can drag that onto our animator, this mechanism system here, and you can see that it's created a move from the entry state straight into our avatar. And this is for both our avatars now because they share the same controller that we're defining here. And if we press play, you will see when it loads, both of them are dancing nicely in sync. Looking quite good, if I say so myself. So that is how to import an avatar, both from the Unity store and from an external source, like Mixamo.
And that wraps up our tutorial on importing and setting up virtual characters in Unity. We explored different ways to bring avatars into our project. We also looked at configuring avatars, applying animations, and ensuring smooth movement using Unity's animator system. By now, you should have a solid understanding of how to bring characters into Unity and how to get them moving with animations. Try experimenting with different avatars, animations, and settings to customize your project even further. Thanks for watching and stay tuned for more Unity tutorials.
Hi, in this video, we're going to be showing how to induce embodiment or the illusion of body ownership over a virtual avatar using Unity and mobile VR. And in this case, we're going to be using Google Cardboard Box. Now, or Google Cardboard. Now, there's a previous video on how to install Google Cardboard and how to use and set up mobile VR. If you haven't already got that set up on your laptops or computers, then please see that previous video. If you are ready, then let's go. As you can see, I already have my Unity 3D software open before me. Now the first thing I want to do is set up my background and make sure that all the right scripts are imported and dropped into my scene. So what I'm going to do is I'm going to my folder Google VR, and the first thing I want is the event manager. So a quick way of finding this is just to type it in the search bar. Event system. The good thing is that Google VR already provides you with a prefab with the event
system with the script already attached to it. So we're going to drop that into our scene. As you can see on the right in the inspector, we have the script already attached. The next thing that we need is our demo scene manager, which will allow us to exit the scene using the escape. So we're going to type that in as well. And once again, Unity and the Google VR package already provides us with a prefab. So we're going to also drop that in the scene. Fantastic, we're off to a great start. Now, the most important thing that we need is our avatar. So, if you haven't already downloaded an avatar, you can go into the asset store and find an avatar that has high fidelity and morph targets. The keywords to look for are morph and mechanism or mechanism rigging. This will tell us that our avatar is ready to be manipulated and very realistic. Also, the morph tells us that the avatar has blend shapes, which allows us to manipulate the facial expressions and features. So once you have an avatar with those aspects, you download them into your scene. Now I have already have mine downloaded, so I'm just going to drop my character into the scene. And I'm going to clothe him. So I'm going to go to my cloth file and put on his suit. I do this by dragging the asset onto the avatar. Now he's clothed. Now, as with mobile VR, we can't move our bodies. So we want our avatar to be seated, so we still feel that illusion of ownership, since we are also seated as we work. So what another asset that we could use is a chair. So onto our asset store tab and we type in chair. There are many assets that we can use. So once you have the asset that you would like, simply click on it and download into Unity. Now, I also have a chair ready for myself to use. So once I have those two assets, then I can seat my avatar. Now this takes a bit of fiddling. So I'm going to open up a version of this avatar which has already been manipulated to be seated. But before that, there's a few things that we need to add to our avatar. One, importantly, is the camera, the main camera, which will be what we'll be using to look around our scene and look at our bodies. So we're going to add a main camera to our avatar. So we're going to camera, and we're going to add that in, and we're going to call that main camera. Now that we have that, we also need to attach this to our avatar. I'm just going to rotate that so it's facing the same way our avatar is. So, as the camera is meant to be where our eyes will be looking, we're going to place this within the subchildren of the avatar. So we're going to open up our avatar to the skeleton, where his body is broken down. And we're going to find where his neck is. So now we have the upper, neck upper and head. So we want to put that camera somewhere in between this place here. So we're going to position the camera to be first in front of our avatar and also roughly where the neck meets the head. And slightly higher. So once you get that roughly in position, then you can add your main camera as a sub-child of neck upper. So now, every time you move your avatar, you also move the camera without changing the position of it on the body. Now another thing we can do is remove the head. So when we're looking, we don't see from inside the head, or we don't see the features of the face. So we're going to just click on that head and move it down, so it's out the way. So I know that looks quite creepy, but it all is a means to an end, I promise. So now that we have that set up, we're going to double check that we have all the scripts necessary to run this in Google Cardboard. So we have our event system, demo scene manager, and we have our camera. Another thing we can add is a pointer. This is not exactly necessary for the camera, but for future use, such as interaction, this will be a good thing to add. So as you can see, we have a range of scripts, GVR controller, and we also have a prefab, which has everything connected. So this allows for interaction. So once we have all the necessary scripts and we've set up the position that we want, then we can seat our avatar. As this takes quite a bit of fumbling, I've already got a pre-made version to show you how it will look like. So I'm going to deselect the version that we've just added now and select our pre-made version. As you can see, we have our avatar seated. And I've seated him in as much of a natural position as I could, which is hands on our lap. So to get the full effect of the body ownership, it's best once we put the Google Cardboard on to place our hands in roughly the same position. So once we're happy with that, then we will go to build settings and make sure that in player settings, we have our virtual reality supported and that the SDK is switched to cardboard. Also remember to name your bundle, your package name. So I've called it Coursera Mobile VR. Once that's all done, make sure that your platform's on Android. And if not, switch it over and then build. I've named my build test and I'm saving it to my project folder. So now it's currently building and finding the Android SDK and the Java SDK, which should both be installed onto your laptop or computer. Once it's found those SDKs, it will start to build. So once that has finished building, then it will open up the folder with your APK in there, which you'll have to put on your Android phone. Once you have this on your Android phone, then you can run it and hopefully see the body or the avatar. And if you look down, you should be able to see the body in the same position or roughly the same position as your own. To get the best results, remember to try and place your hands on your lap, similar to how it is in the demo. A few things to check on your phone before running is that you are on developer mode, and also that your phone supports third-party applications. Then it should run completely fine. So give that a go and see how you get on.
Hello, this is the project I'm going to guide you through during this course. As you can see, there's a character there who's responding to my speech. He looks like he's listening to me. And when I stop talking, he will start talking to me. And if I nod, he will respond to me. Hello, welcome to our VR virtual characters demo. Would you like to find out more? I'm a virtual character programmed to respond to you with realistic body language. So I'm going to take you through the requirements for the project. First off, there should be a scene that's viewable in VR. That's quite straightforward. There are a couple, by the way, that I've left out, which are to do with how you document your project. I'm not going to worry about those today. But the first one about the actual end result is that it should be viewable in VR, and that the player should contain a virtual character. The virtual character should be animated. The virtual character should include body animation and facial or gaze animation. And the character should respond to the player's actions in one or more ways that are similar to real human interaction. So I quickly want to go through each of those when I'm showing you the demo we've got. So here's our virtual character. There is a virtual character. That's requirement 1. The virtual character is animated. Our VR virtual characters demo. He's responding to me, as you can see. He's talking and his animations are based on the body and the face. So both his eyes, his facial expression, and he has some small body movements, not that much now that he's listening, but if I let him talk like a virtual character programmed to respond to you, you can see that he has plenty of gestures that are responding to me. So we can see that all of the requirements, the scene is viewable in VR, the project should contain a virtual character that should be animated, should include body and face or gaze animation, and should respond to the player. They're all hit by this project, and over the next couple of weeks, Tara and I are going to guide you through how to create that character.